In this video, we're going to talk about the moving and additivity principles for area. The moving principle just says that if I have a shape and I move it, as long as I don't stretch it or shrink it, so I move it rigidly, moving it or relocating it doesn't change the area. The area of my red rectangle here is the same as my area over here. The additivity principle says that if I combine shapes, again, I'm not stretching or shrinking them, but if I just combine shapes and I know the area, for example, of the blue rectangle and of the green triangle, then I can just add those two areas together and the total figure that I've created is the sum of the two areas. So I can independently find the area of the triangle, the area of the rectangle, and then I will add them together. Here it's really important that we don't overlap the two shapes. Let's use these to solve some problems. We'll look at several different strategies for basic area problem solving. So if my task is to find the area of this irregular shape, the first thing I could do is break it down into shapes that I can easily find the area of. First, I can see a rectangle in there. I know that the area formula for a rectangle is length times width. I'm counting spaces here. So this is 2 units, and this is 4 units. So the area of my first shape in there is 8 square units. Area of the second shape that I've labeled is also a rectangle. So it's still length times width, and we have a 1 unit by 2 unit rectangle. And then I'm just left with adding up the remaining triangles that I have there. The area of one of these triangles I can see is just half of a unit. It's half of a square, and I have 1, 2, 3, 4 of these units. So I add up half a square unit plus half a square unit is 1 square unit, and these form a second square unit. Now we have all of the information we need to find the total area. We'll add the area of each individual subshape together to get this total, which gives us 8 square units plus 2 square units. Uh-oh, I found a mistake. Do you guys see it? Area is a 2-dimensional unit, so if I have 1 unit here, when I form the square, that is a square unit here. So I needed a square in there to convey that I'm talking about a 2-dimensional measurement. So I end up with 12 square units. So what did I do here? I just cut my composite shape into shapes that I could easily determine the area and then added them together. Let's do this with another strategy. Let's use a takeaway strategy next. What I'm going to do here is I'm going to surround my given shape with a shape that I know the area of. So I'm going to surround this with a rectangle. My total area comes from the sum of the area of the original shape plus the area of the new regions that I added in. But this means that I can find the area of my unknown given shape by subtracting. So if I subtract away from the red total area, the green area, and the orange area, I'll be left with my original area. So again, I'm taking this new area and I'm subtracting away the green and the orange areas that I added in, and that'll leave me with my original area. So let's go ahead and do that. Here I have a rectangle, so that's going to be length times width. I count my spaces, 1, 2, 3, 4 units tall. and 1, 2, 3, 4. Oh, I have a square, nice. 4 units wide. So that's going to be 16 square units. My orange triangle is easy. That's just half of a square unit. In my green triangle, I'm going to go with some rudimentary counting right here. 1 square unit, 2 square units, 2.5, 3, 3.5. So I can take my total and subtract away the green and the orange, and I'll be left with the original. And this is the same value that I got above, which regardless of the method, I should always end up with the same value. Let's go with another strategy. Move and reattach. Sometimes we can look at a shape and see that if I could just rearrange, then I would have something easy to work with. I can see that this triangle right here, I'm going to relocate it. The base is 2 units long. The height is 1 unit tall. So I can just relocate it over here. Now I have a full rectangle. I can use my area formula of length times width. I have 1, 2, 3 units and 1, 2, 3, 4 units. And I have 12 square units right there. One more strategy here, guys. This one we'll be using when we figure out area formulas for some other polygons. So let's practice it with this irregular shape. So I'm gonna combine 2 copies and then cut them in half. So let's start by cutting this shape. I'm going to copy it. Then I'm going to rotate it because this one I picked because they'll fit nicely together. And you can see that I have now a rectangle. So I can just figure out the area of the rectangle, but I only need half of the area of the rectangle because I've doubled it here. So this is 1, 2, 3, 4, 5, 6 spaces tall, so 6 units. And it's 1, 2, 3, 4 spaces, 4 units. So my area that I want is going to be 1/2 of the new shape. The new shape is a rectangle. The length is 6 units, the width is 4 units. Half of 24 square units gives me 12 square units. So by reproducing, copying the shape, rotating it around, fitting it back together, I had an easy rectangle and I could just have it because I had doubled it to make the rectangle. So those are 4 strategies that are going to come in handy as you're finding areas of shapes, and we're allowed to do them because of the moving and additivity principles about area.